Hello, everyone. Welcome to the Hustle AI podcast. We are your hosts, Jitin and Sunena. Before we get started, a quick introduction about us. I am Jitin. I'm the CEO and co-founder at MicroGigs. At MicroGigs, we use AI to help you build software products better, faster, and for less. So what we do is that leveraging AI, we automate different stages of software development process, which allows you to focus less on the development overheads and more on your ideas, and indirectly saving you time and money. In general, like my background has been in tech. I played different roles from software developer to different tech leadership roles. And I have with me a friend of mine, Sunena. So Sunena, why don't you give us a quick background about yourself before we get started?
Awesome. Thanks, Jithin. Hi, everyone. My name is Sunena. I'm a tech enthusiast and I have a background in product management. I'm really interested in learning about how AI can help us live happier lives. And I also love exploring different ideas and meeting with different people with different backgrounds and looking forward to exploring that in this podcast.
Awesome. So Sunan and I, we have been working together like maybe for last 3 to 4 years. We used to work together at TD, and while we were working, we used to have a lot of discussions and like brainstorming on how we could make the software development process better. And like with the recent trend in AI appearing on the scene, so we know that like we could cut short that journey. So maybe AI allows us to genuinely like make this process, remove the overheads, and kind of like get to a stage where software development is straight away between ideas to seeing something tangible in front of you. So we were having a lot of discussions on this topic, and so we thought, why not open up this topic to the general audience? We'd love to hear your ideas, your thoughts as we are discussing. We just don't want to keep these discussions between ourselves. So that was the idea behind this podcast. So Sunera, what do you have to say to this?
I think that's a great idea. Can't wait to start.
Awesome. Okay. Yeah. So as part of this process, we would be inviting some very interesting people. I would love to get their perspectives on how AI is going to impact their day-to-day lives, how their job, and so on. So welcome. So you could find more details about us in the description below. And without wasting time, let's get started. Today we have a special guest with us, Francis Jeanson. Francis, I would say like most of us got introduced to this world of AI maybe in the last 3 to 4 months. But with Francis, he's been in this space for over more than 21 years. Is that correct?
Yeah.
Okay. Oh, yeah. So Francis is like a health data analytics and AI expert. He's been working with a lot of the healthcare space, helping using AI and how we could help build by better products. So that's been like Francis' main expert. I'll let Francis introduce himself and give a little bit more background on what he's been doing on a day-to-day basis. So on that note, Francis, why don't you tell our listeners what you've been up to?
Hi, everybody. And thanks, Jitin and Sunena, for having me today. Well, I can give you a bit of background. So 21 years, that's just kind of broad. I think I really got into the field after high school because of interest in just like computer science and how machines worked, and realizing that it would be amazing to just even be able to converse with a computer in the early days, right? So discovered a really exciting program at University of Toronto, here in Toronto, called Cognitive Science and Artificial Intelligence, which I started in 2001. So that was, about 22 years ago. And it's that was the beginning. And it's just learning about, so cognition is the broader sort of domain that studies, it's an interdisciplinary study and domain field of study that tries to bring together ideas and theories and concepts from a wide variety of fields, but the primary, domains that usually study in cognitive science is philosophy, and primarily philosophy of mind. So how does the mind work from a philosophical standpoint? So really thinking about thought experiments and hypothetical sort of situations, and really understand it in depth, looking at a large body of work and expertise from the last 100 to 200 years. Another big aspect of cognitive science is psychology, and cognitive psychology in particular. So really, what are the mechanisms that underlie how we think from a biological standpoint, from a neurological standpoint, et cetera. A third major domain is linguistics. So how do we do this amazing thing, which is to speak and to understand each other and communicate? And then the fourth major domain, which obviously I think everybody's familiar with, is computer science. And that's really actually where the term artificial intelligence really came from, is the sort of the domain of computer science. And in the 50s, I think it's 1956, where a number of very big thinkers, academics from primarily, I think, America and Europe came together at Dartmouth University in the US. And they had sort of, I think it was like a summer workshop just to think about what can we do with computers. There's the field of cybernetics, which had just come out from the first half of the previous century, so the early 1900s to 1950s. They were looking at control systems, looking at biological systems, etc. And others realizing that we could really do sophisticated things with computers, and primarily thinking about the Turing completeness, and the fact that Turing machines, which Alan Turing helped develop during the Second World War, were really powerful things. So all of that was just so fascinating to me, and that's how I kind of got in the field. And from there on, I kind of did a master's in evolutionary and adaptive systems, so looking at more of the biological sort of systems, then a PhD in neural coding, so really looking at how does the brain actually do some of this processing itself. And so that took me to the 2010s. 2013 is when I defended my PhD, and had been working then. I really saw the opportunity especially in the neuroscience and research space, to make use of new technologies for advancing our understanding of how the brain works. And so I started working with organizations like the Ontario Brain Institute here in Ontario, to help research labs and experts across the field of neuroscience bring their data together and try to understand how can they better understand the brain, and especially also the brain of people who unfortunately suffer from various brain disorders. And there's so much to learn, and there's so much data, and yet we've just started to scratch the surface of understanding how these disorders work.
Very interesting. Very interesting. Yeah. So, I guess you know this better. Like I say, most of us, our exposure to AI has been on the generative side, right? Like text generative, domains and image generation and so on. And just by that itself, we are kind of awestruck as in what all we could achieve, right? And I guess it's the first time this happened in the last, I guess in the 3-4 months, where people got to experiment with AI, right? Before this, people's exposure has been maybe in theories and learning, or maybe to some extent in sci-fi, works and so on, right? But here, first time you're getting to see all that stuff. Now you have been in this space, researching AI, or rather using AI to kind of not just please excuse me, not just to write essays, but to make something do something more useful here, right? So how have you seen this evolution? Of course, AI has been an expensive, it's expensive, right? Even the training the models, you need to invest a lot in that. And say before and after AI, what has been the world been like to you, especially when you're trying to solve more complex problems in this space? So just taking a step back, my question is twofold. One is the evolution of AI, and how you have seen its evolution. And second is, have you been using that to solve more of complex problems?
Yeah, definitely. I mean, I think it ties in also to the whole ecosystem of people researching this. Then it was really like a research lab sort of domain of study, even I'd say 15 years ago. And up till the early 2010s is, I think, when it really became something more accessible to a lot of developers, and the whole development and engineering community beyond the research lab that were just developing these sophisticated algorithms, right? That would train computers and to learn how to classify patterns, right? How to generate text, how to interpret natural language, detect patterns from visual input and images, etc. That was really a lab thing up to the 2010s. And I think in 2010, there's really a big shift once the neural networks were put to better use through lots of computation, like powerful computers, but also a lot of data, right? A lot of data being available. And that was a really big shift. And the modeling had also become mature enough to enable that modeling by many folks and a lot of people, not only within academia, but even beyond academia, who were comfortable with working with libraries of code, developing open source projects and collaborating on these projects. And that really, I think, is what led to the sort of explosion of modern AI. It's the leveraging of these packages and tools, which didn't really exist back in the 2000s, right? You'd have to program your neural network from scratch, right? So you'd have to develop a way of representing your data structures and writing algorithms that would compute your matrix multiplications and design the input biases and thresholds and compute the error rates so that you can back propagate to the network if you're doing neural networks. And that was all very manual 15 years ago. And I guess about 10 years ago, 12 years ago, large packages or platforms started to come out. And today we all know, the TensorFlows and the PyTorches. And at some point, I think there was Caffe and there were others even before that helped in the early days. But now that's really what's enabled the wide scale adoption and use that we're seeing today. And that to me is, I think, the really exciting part. It's just becoming more accessible to everybody.
Very interesting.
Yeah.
Okay.
Yeah.
Like on that, I have a follow-up question. Let's say, are you able to give an example, or maybe some of the work you do in terms of, let's say, using AI, to solve the problems related to brain functions and all? Is there something you could think of?
Sure. Yeah. So there's different areas that are really interesting. But I think so. One of the big issues with traditional sort of statistical methods is that you're limited by typically you're limited by the not necessarily the amount of data, but by the noise in the data and the amount of variability that you have in the data. And so traditionally, because of these traditional statistical methods, you'd have to really clean that data to a very large extent. You'd have to really come up with a crystal clean data set so you could really perform good comparisons and ultimately find a way to have what you call statistical significance to separate categories, for example, within your data set. And what machine learning has allowed us to do, and when I say machine learning, I mean it broadly. We're not just talking about the classification and sort of supervised learning approaches, but also even the unsupervised sort of clustering and ways of sort of aggregating data into subsets automatically. Those methods are really, really good at dealing with noise and dealing with the variety that we have from the data. And they also benefit from the vast amount of data. So the great sort of combination there is that you can throw a lot of data at it. Sure, you do need, and it does benefit sometimes from some refinement and some what we call feature engineering, but it's to a much lesser extent to what you would need to do on if you're using more traditional statistical methods.
I see. Okay.
Yeah. So it's great. I mean, they're just getting better, right? We're seeing now these big models, like the more foundational models, like GPT, that are really good at dealing with almost any data.
Yeah, okay. That's interesting. We might circle back on this. Let's just move on to some other topic.
Yeah.
So, I see you have a big list. So
you actually asked one of my questions, but a follow up to that actually is, what are some of the most exciting areas or rather problems that you're trying to solve? And I know that you mentioned that AI is helping to clean out the noise and make that or speed up that research process. So I guess what is the most exciting problem you're trying to solve?
Yeah, it's a good question. I think one of the really hot topics right now in health and medicine, and so research for health is around what we call precision medicine or precision health. And the idea there is to be able to not only see patterns within a large population, and traditionally what we would do is we would look for subgroups. So is there a subpopulation within this large population that maybe we can divide that population into 2 groups, or maybe 3 groups or 4 groups, and then come up with better treatments for these subgroups because we understand them better. That's pretty much the status or the state that we're at right now. But what we can do and what the field is really aiming to do and what machine learning will help us achieve, I really believe, is get to a much more precise sort of either diagnosis of a patient who has a certain disorder, but also potentially predict the trajectory and ultimately come with better ideas on what treatment would better serve that individual. Because each one of us is a little bit different.
Yeah.
And we may not all respond the same way to specific environmental factors that affect our health. Mm-hmm. We may not all respond the same way to various types of medications or treatments. And that's another really interesting and exciting area is some patients respond really well to what we call clinical guidelines. So the sort of the standard that the medical practice of that domain decided on what was the best treatment. But that might only correspond to 40, 50, 60% of the population. But what do you do with the remainder? Well, these standards of care, they don't work. These standards are either medications or it could be a type of therapy. They just don't work. And so we need to look for better therapies to target those individuals more specifically. And so that's, I think, a really exciting area. And if we want to tie it back to sort of the space of traditional AI or the theory of AI, you can think of it, for those, I guess, who are listening who are more, of that background, we can think of it of the problem of coming from a general population to a point of creating like a, what you would call instantiation. So you go from a generalized sort of model of the world to the point where you can interpret individual instances, so individual people in the case of health, so that you can then make a better decision on those instances, on those individuals.
That is very interesting. I mean, let's say, just to draw a parallel line here, right? Let's say today, most of the streaming, the websites out there, right? YouTube, Netflix, whatever, even the Instagram, whatnot, right? They all know like what my preferences are, right? So the moment I open up those screen, based on my like past behaviors or my past interactions, like it keeps loading all the new content, right?
Exactly.
So here you are somewhat talking to like applying the similar theory in the medical domain, right?
That's right.
Based on your past behavior or habits or something, what is the ideal treatment that would work for you versus for someone else? I know that's actually okay. That's actually that's very interesting.
Yeah, okay. and I think that's exactly it. And there are some really effective algorithms that work for these sort of recommender systems.
Yeah.
And I think we want to come in health. There is a need for these type of recommender systems for the individuals, just like you said, just like for individuals in like looking at videos on certain streaming service. I think the big challenge with health is that the number of factors that lead to a certain disorder are huge. You're talking about hundreds, if not thousands, of potential factors.
Interesting.
Whereas when you're looking at streaming service, there's maybe a dozen factors, like the types of content that you're looking at, the types of content that who you're friends with, and what do they look at factors around like the timing of the day, and there are certainly lots of different factors, but not nearly as many as what you would have from a biological and a health perspective.
Interesting, very interesting.
Yeah,
okay.
Yeah.
So it all comes down to data collection and how you do it properly.
Yeah, that's a huge deal. So it's interesting. So it's especially true today. I think it may actually become less and less true in the future. I think we'll actually be, because the machine learning and the techniques that we have, the algorithmic techniques that we have to manipulate data will actually become better and more automated, that this issue of sort of data cleaning or there's also the idea of data harmonization will be more automatable. That's a bit of a dream right now. I mean, but I do think we'll get there. I think we'll be able to do that more and more.
And at what stage is this? I mean, is this put to practice as of now? Is this already being followed, or is it still in its theory, research, or like trial stages?
Yeah, that's a good question. Yeah, so I don't know if everybody's familiar with the innovation curve, but so there's different things here that are on different stages of the curve. As you know, the techniques and the platforms that we have for modeling are definitely, I would say, probably past that peak of innovation. Like now we're really at the point of sort of, even disillusionment, I hope, at least in the engineering sense, is sort of past. And now we're really starting to see very productive systems that are very effective and have huge impact on how we do things on a day-to-day. But there are areas like this data cleaning, data feature sort of extraction, harmonization, which I think we're still in the early stages. And it's more at the lab level, the research level. Yeah. And we're seeing some of these things put into practice. Probably one of the most exciting ones that have, I think caught on, and we have a number of even startups that are creating exciting products around this, is around what we call synthetic data generation. So this is where you're taking a data set and you're able to either amplify it in terms of like adding more samples that don't exist in the original data set, or you're able to add characteristics to the original data set that didn't exist before. So you're like removing maybe biases, for example, which is really exciting, because that can have a huge impact on benefiting models like AI models. And the third area is around privacy. And in some cases, you don't want to share personal information about people or about places, about institutions. And so what you want to do is you can remove, well, you don't need to remove in the traditional sense. You just create a synthetic version of that data that preserves the statistical properties of the original data, but doesn't contain any of the original data. So you really preserve that privacy, but you have the interesting scientific sort of characteristics of the data preserved that you can analyze from that synthetic version.
Very interesting.
Yeah.
And one thing I'm excited of like this is like say, we all know in today's world, like healthcare systems across because most of the world is taking a toll, right? I mean, again, like different reasons, then one reason could be maybe the world population is aging. Like second could be, the diseases could be like are different from what maybe, our previous generation had because of our modern lifestyles and all that, right? I mean, we are like more like, sedentary workers than like active like workers, right? Now, even let's say if something of this nature materializes, even like if you could reduce the diagnosis time, that means less pressure on the healthcare systems, on the healthcare staff. I mean, much faster treatments, like better lives for everyone, which is exciting.
Yeah. It's a huge deal. There's a big challenge related to that. So early diagnosis, it has a huge impact on like usually the outcomes for the patients are going to be much better if you can diagnose it earlier.
Yeah.
There's big issues and pressure on the healthcare system, like you say, around what you call readmittance. So a type of treatment doesn't work, or type of maybe they had a procedure like a surgery. And there's some complications and that don't appear right away, but maybe they appear 2 or 3 weeks, so they're readmitted to the hospital. That creates a huge amount of pressure on the health system. So if you can predict those things by measuring everything about like the type of procedure that they received, the timing at which they received it, what were they, maybe you can capture things around, obviously like their history, their medical history, other factors that they're at risk. Maybe you can do even some genetic analysis to look at maybe predispositions to certain conditions. Are they at higher risk of developing inflammation or whatnot? If you can measure all these things, then you can build better predictive models for that individual in a more precise way. That precision medicine, again, sort of approach, which then reduces the burden on the healthcare system tremendously if we're successful at it.
Interesting, very interesting.
Yeah.
All right, anyways, I guess we got caught up in this topic. It's a very interesting topic, very interesting, okay, let's switch gears. So now maybe you could continue with the next question you have.
Oh, okay. I didn't that was really structured. But sure. So you talked in the beginning about cognitive science and your interest in the nature of intelligence. I'm curious about your thoughts of where AI is essentially, we're watching intelligence evolve. So it's a very abstract question, but what are your thoughts on generalized AGI and how that will evolve over time?
Yeah, it's a really good question. I think a lot of folks would like to know. There's something I came to realize after maybe like midway through my recent career, I guess, in AI, is kind of like there's some fundamental constraints that we need to work with to understand, I think, intelligence. And traditionally, a lot of like people in the field, they like to think about intelligence as, okay, well, you're able to reason, you're able to problem solve, you're able to learn. Those are all good characteristics generally of what intelligence are. But I think we need to have a better framework to help us really make progress so that we essentially constrain what we're focused on when we're trying to develop these systems and realize what are the key features that really make a system extremely performant in the sense that they can actually be, they can perform generalized tasks. So that's one of the hallmarks of what people are hoping to achieve. And so providing that framework, that theoretical framework, I think is going to be really important. And then obviously like working on these systems and experimenting with systems, and some of it might be guided by the theoretical frameworks and the different ideas. But often in science, we have great discoveries that happen by accident. And I think that's also something that we're likely going to be, I hope, right? The more people we have working on this, the better chance we have of having really good accidents, right? Hopefully good ones, not bad ones. But if we have good accidents, then we are going to likely stumble on some really amazing systems that can do things that we didn't thought they could do. And maybe it's like some of these new models, like these what we call foundational models like for language, are starting to be able to really showcase some of this. But there's still some limitations, and so the question is, how do we bring it to the next level? That's where I think the theoretical framework really helps. And some of the core concepts I think that we always need to think about when we talk about AI systems are kind of like the 4 levels of intelligence, so to speak. The first, to me, is really memory. You need a system that has the capacity to memorize things, because without memory, there's no way you can really learn. There's nothing you can use from the past to act in the present or the future. The second level is learning. You need a system that's able to use those memories to learn, to see, okay, well, I've done something bad here, it didn't work out, I need to improve how I'm doing things, and I'm going to change how I do things so I can do things better. That simple learning system is really key. And when we say machine learning, that's essentially the level that we're at today. The third level is prediction, but not just prediction in the sense that you're making an inference, which is actually what we mean most of the time in current day machine learning language, is when we say that the model is making a prediction. What we actually mean is the model is making an inference, meaning it's making a decision on whether it's class A or class B, right, based on the input that it received. But what I mean by prediction is really predicting in the future, anticipating, right, what the state of the world or the state of your body or the state of things are going to be a few time steps away. It could be a couple seconds away, but it could be, a year away, that or even further down the line. That capability for prediction is really fundamental, and we're actually pretty good at it. Humans are actually really good at prediction. We can anticipate how humans are going to behave based on what we do. We can anticipate how, a car that is driving down the street and is going too fast is probably going to slip and continue maybe and have an accident. Like, we can predict these things quite well based on past experience and based on the models, the representations that we have in our heads that our brains are able to do. So that's number 3. Number 4 is control. And I don't mean control in a bad way. I just mean a system that's able to manipulate not only its body, like a robot would do, or us were able to do, but also manipulate the environments, right? So change things, do things so that it improves the way that you're able to sort of live in your environment and with your peers and with everybody that's around you. An interesting and kind of neat thing about this is that the better you are actually controlling your environment, the less you need to learn and predict, because you've actually simplified the space for you. Okay. So that's kind of a neat relationship. And there's some really cool theories around this that are related to this concept, like active inference, for example. I think Carl Friston and some colleagues in the space are very popular right now in this research space, because they're talking about this idea of, you're actively inferencing sort of your state and the state of the environment so that you can improve your state accordingly. So, but that framework will help. It doesn't mean that accidents won't also help, right? I think they will. So it's going to be a bit of a combination.
That's very interesting. I like now, since you mentioned that, as of now, I guess, of course, the last part of manipulation, I think we might still be far away from that, because that's a much more complicated task. But everything else is just at least happening in silos, right? You have say that the Tesla's intelligence, which is helping guide the cars across the roads of North America. You have all the streaming sites, which is very good at predicting what you would like watching on this day, and accordingly it does recommend stuff and keeps you engaged. So in some way, these machines are already manipulating us, right? I might be getting a good sleep, but it might just pop up something. I just go into a rabbit hole. So it did it, right? It manipulated me, kind of environment, right? And then again, we have this, all these things with generative text and generative content, everyone is oh, this is amazing. Where we might be employing a faculty of thinking, or even, let's say, spending that 30 seconds, so this is how I think of a problem. We are now stepping back from at least that evolutionary process, right? We are not even going to activate a brain, at least in those things, right?
That's true. Yeah, exactly.
So what do you where do you see the culmination of this? All these things are happening in silos, right? At some point it might get connected. What are your thoughts on that? Is it really going to happen now that suppose if, let's say, someone was to look at, let's say, the design of a human body, right? We know somebody is working on the hand, somebody is working on the leg, someone is working on the eyes, but they haven't integrated the human body together, right? But here, at least, drawing a similar parallel line, along with that, we have all these things happening in silos, and what's next?
Yeah. I mean, I don't know. I don't know what's next. I'm trying to predict as well, but my predictive capabilities are limited, like I guess anybody. But it's I mean, the area is super exciting. There's a lot of work happening in different domains. I mean, we have to think of the complexity of what we're dealing with, and some of the limitations that we have right now is based on like we're thinking of these foundational models. They take billions of parameters, right? Like parameters are weights essentially of the neural network. Where I think GPT-3 was 175 billion parameters, if I remember correctly. That's massive, and it was trained on over 500 billion tokens, or it's around there. Like huge number of tokens are like words essentially in the text body that they split up sentences into tokens. Massive, right? Huge. Like I don't know how much time it took them to train that model, but it's probably weeks, if not months. I don't know. Obviously, the more compute you have, the faster it goes. But that's a huge challenge. Is around like how do we make this available for everybody? How do you build off of this when there's only a few large organizations who have access to this as the base? So it's great. Like they're building APIs, etc. Like you mentioned earlier. You can leverage these APIs to start building neural models, etc. So I'm hoping that will continue. But I think a big challenge generally is that these methods are highly compute intense. And when you look at the brain of a human being, it doesn't require nearly that much energy, right? The brain of a human being, I think, takes on average, and this is plus or minus 10 or 20%, but it's around 100 watts, I think, right, of energy, I think per hour, I guess, if you look at watt hours, versus these computers that would consume, megawatts, if not at least kilowatts, if not megawatts, based on the amount of GPUs and parallel processing that you have. So the efficiency of the brain is huge. Okay, so it's to be fair, you have to take into account that we grew, right? We had time to mature.
We had the luxury of over like a billion plus years through different species. Right?
Yeah, there's evolution. You're right. So there's evolution, and then there's even our own like growth during our lifetime, like the 20, 30. I guess you could say a pretty mature. I think Jean Piaget was like one of the early psychologists who studied development in children. By the age of 8 to 10, I guess you reach kind of like your mature sort of psychological sort of level, and you're able to do really sophisticated things. Like children are actually able. They're very capable already at that young age. Yeah. So it took us a few years. So that takes a lot of energy, but I think the important lesson here is that there's actually a bit of a design map as to how do you architect a system that can actually learn very, very quickly, just from a few experiences in the real world, how to reason about that world, how to learn, predict, and control that world, control their own body, and have conversations with others, become part of a social network, etc. Those are really at the basis of that is sort of a crystallized model that is the brain, right? And the body that are able to interact with the environment to do these things. And it takes very little energy when you think about it. And we are not quite there yet. So there's a lot of work, and I think a lot of insight that we still need to do around designing more efficient systems, because it's possible. In principle, it's possible. Right? Okay. The world has, like, nature found a solution. So now we need to find a solution as well.
Okay. It's also, just the thought of it, right? Like, okay, someone that we created who's like could be equally intelligent as us, right? Or maybe more. Anyways.
Definitely, So
like on that note, right? Let me, if you could just give your thoughts. You mentioned that you study a lot of on the cognitive processing, like brain functions and all, right? Yeah. So just from your perspective, what is it that makes a human? What is it that makes a human brain? I know this is not getting too philosophical, but at least how thinking of from the perspective of a brain and a mind, and
biologically,
biologically a little bit, psychologically, combination of these things, right?
Yeah, we're pretty complex. There's, we have evolutionary constraints that have forced us to, our evolve in a very challenging world. There's a lot of if we abide by the traditional Darwinist sort of theory of sort of natural selection and evolution, the core idea there is survival. And so you want to be able to live long enough so you can reproduce and have offspring, which is kind of the truth for all living things, whether you're plants or an animal or a human. So I think there's lots of these fundamental constraints that have dictated how our brains and how our bodies work. And, in the early days, adaptive theory talks about the 4 F's of adaptive sort of intelligence or adaptive behavior. The first F is fighting. The second F is feeding. The third F is around fleeing, and the fourth is reproduction, which I won't say. But basically, you have those 4 fundamental things that we do and we have to do to survive. And that when you think about those fundamental principles, we were talking about principles earlier, those are really fundamental to any living system. And because there's such good, simple, basic strategies for survival. Like if you see a really big threat, you run.
Yeah.
If you see something that's not a big threat that you think you can overcome, then you fight. You need food to survive, so you need to feed, and you need to reproduce if you want to have offspring and pass on, your genetic makeup, etc. So those are really fundamental things, and I think so to do those things, like especially, feeding, all of them actually probably require some level of emotional response. And that's something that, interestingly, we often think is a unique thing to humans and maybe and animals. I think to some extent, a lot of folks would agree that animals also have a lot of sort of emotional response. And I'd argue every living thing needs to have some sort of emotional response. It might not be at the same level as us, but even plants, to some extent, they might start to retract if you bring a source of heat that's too strong, etc. Like that's a fundamental thing you need to have. So, and that's not something that when we think of intelligence as being something fundamental, emotional response. But when we think about our origin is evolution, right? The origin of machines and like machine learning or AGI, artificial general intelligence, their origin comes from humans, comes from us, the scientists and the engineers who try to build it. Yeah. Do they need to have emotion? It's a good question. I don't know. I think if they want to interact with us in a social context, they probably do.
Maybe.
It's going to be hard otherwise for us to relate and to communicate. But maybe they don't. I don't know. Those are good questions.
So, do they have to give us the illusion of emotion, or do they have to be conscious?
Well, that's a great point onto itself. So can it be so? The illusion of emotion is an interesting idea. There's actually some philosophers that talked about this a little bit as hypotheticals for why it may be possible for individuals to exist that have all the intelligence of a human but don't actually have the consciousness and sort of the emotional capabilities of humans. And if you look at the zombie thought experiments, I can't remember which philosophers now off the top of my head, and I know it's more recently there's been others, but yeah, it's been a bit of an ongoing debate, and it's kind of this thought experiment as to, is it possible to have intelligence without sort of consciousness in the way that we think of consciousness?
That's actually, I think the point that you mentioned, right? Somewhere there were some evolutionary constraints which got us to this stage, right? Like whatever it is, right? Like now, for systems or machines which doesn't have those constraints. Now, I don't know if artificially you're programming it something, because as of now today, like all the AI systems are all more like your followers, right? You give it an instruction, it will do something for you. Mm-hmm. There is no motive for it to do something of its own, right? We have this motive of doing because somewhere in our DNA, like I guess in all the animals and all the species, it's like whatever multiplication. So that leads us to do all kind of stuff, right? Mm-hmm. We building buildings or someone building Taj Mahal or all that stuff, or pyramids and all that stuff is to either making sure that gene line continues or to impress someone or something of that nature, right? Now, like in that context over here, when the machines doesn't when they don't have this motive, and if that could be I don't know, now in the absence of consciousness, does it need intelligence, or is it just going to be a follower to humans, right? Maybe we might just have a perpetual servant, right? Willing to do anything that we ask them to do it, right?
Yeah, so, that's a great point. And maybe that's all they need. And they don't necessarily need to have their own impetus, right? Their own motivation. But I guess But like you said yourself, yeah, maybe they do, like if we wanted them to be more autonomous and kind of like explore their own things and do all that, maybe they do need to have some sort of like intrinsic motivation to do these things. And what is intrinsic motivation? Is it emotion of some sort? Is it like maybe it's just curiosity? Is curiosity a type of emotion? Those are questions
that's a good point.
Ask others to respond to. But
I mean, like, you could, like, now, like a clear sky, you could look at the moon and you could wonder, wow, this is beautiful. I'm gonna paint a picture. Versus, oh, that's a moon. Maybe I should reach there, right? Where are those questions gonna come from?
Where they come from?
That's interesting.
Where do they come from in our own brains?
Where they come from? Yeah,
It comes from somewhere.
Somewhere. Yeah.
All right. Okay. And this is so far very interesting discussion.
Yeah.
And thanks for coming down. I guess we will mostly wrap it up in 5 to 10 minutes. We're almost there.
Sure.
Just to talk a little bit about, coming back to the use cases you have been using to solve the problems, right? Let's say recently, in terms of what were the challenges? I know you mentioned that, analyzing data at large was a problem, and now with AI, it's comparatively easier. But at the same time, now you have all this data models, a GPT and bunch of models. I guess within a span of next few months, all this, the other big tech, right? Google and Facebook, and they already started releasing some of this. There is a very recent news, I guess just yesterday or day before, that the new APIs that they released were gonna be much cheaper. We are gonna look at something like Moore's law in AI as well, right? The cost of computation coming down.
Yeah.
Now, do you see any are any of these models or data being exposed by this big tech? Is it useful to your line of work, or is it something more for their profit oriented for these big companies?
I think it definitely be used in the health sector as well. The big benefit of these models is that they're multi-purpose. They're a little bit like these general purpose models. They can do multiple tasks. They've essentially been able to integrate huge bodies of language data, right? All these text data from various sources very efficiently, and creates using these attentional-based networks that essentially have really good capacity of understanding the context in which words come from based on this huge body of text. And they're able to generalize and instantiate a little bit, like I talked about earlier, really, really well. And it's mind-boggling to think that they've achieved such great success with what they've done. And so it applies really well in various areas for research and health. Some of the really exciting work that's happening now is kind of looking at wearables and technology that can pick up on sort of what your day-to-day sort of lifestyle and experience, and be able to assess that and see if we can use that data to predict maybe the beginning of a disorder or disease that's starting to emerge. And like I said earlier, the earlier you can detect, the better your chances of treating and outcomes are going to be. And so it's a very active area of research, and I can see these models like GPT that could be used, for example, at analyzing text when you have an interview with your doctor. The doctor could have an interview with you and record that text, and maybe with that text associated with a model that would then say, okay, you're actually speaking in a way that's a little bit different from the way you were speaking last time I saw you a year ago. The way that the prose of your speech, the vocabulary of your speech, etc., and do a better prediction of that. And there's actually startups working on this already, and it's not necessarily using GPT, but I think GPT and others will definitely facilitate this.
Interesting.
Very cool. Yeah, it's very exciting.
And let's say, as you're working with, let's say, the data exposed by or other models exposed by ChatGPT and all, how do you trust this data? Because this has been trained off existing content, right? No one sat around and verified this content. Now, for let's say creating blog posts or some marketing content, all these things are good because it doesn't matter. It's just one idea versus second idea, right? But here, especially when it comes to healthcare and healthcare analytics, is there a process which you measure or verify?
It's a really good question. It relates to the whole problem of ethical AI and trust, the trustworthiness of the AI, explainability of AI. I think when we think about it, humans are the same, right? We trust our doctors. We trust people who've actually gone through the learning of huge bodies of text, huge bodies of knowledge, many hours of instruction. AI
That's a very good analogy. That's a very good analogy.
They're a little bit like us. They've learned obviously from huge, much larger bodies of text, and they're able to do, you could argue, much less because they're not quite as sophisticated, but still they're getting pretty impressive, as we know. And to be honest, you could try to assess, I think, upfront whether, are they validated? Is it trustworthy? Of course, the more we can do that, the faster the adoption will be. But I think also it's going to come from the outsets. Like afterwards, we'll be able to look back and say, yes, actually, it's been trustworthy on this. It's been trustworthy on this. And when our level of confidence of their performance is above a certain threshold, I don't know what that threshold is, but it's, above 90%, 90, 98%, maybe it's 99.99%, I don't know. But above a certain level of threshold where we still tolerate some mistakes, just as a human would, right, make mistakes, then I think that's when we could say, it's achieved, a reasonable level of performance. That makes it great. It makes it now something that can really be part of our society. Yeah.
Okay, that makes sense. And I guess this would be one of the last questions from my end. Say what we were doing at MicroGigs was using AI and figuring out how we could help build software products faster, right? I mean, cutting down the overhead process and making sure there is more clarity for the developers, or even kind of fast tracking development process as well, right? And maybe at some point of time, using the data, using the requirements, can it go around and pick which would be the right code developers should work with? And we are not at least at this stage expecting AI would go out and build all the modules, but at least it will put it in front of developers. These could be the snippets you could use, right? Then that might save them some, 10 minutes in looking up how do you build all that stuff, right?
Yeah.
So, and we were okay, at least when we started this project, maybe a year back, we were okay, we're going to collect data, we're going to analyze, we're going to train our models, but we are planning to give it some time. Now with AI or ChatGPT, on the scenario, especially with OpenAI APIs and all, we know that we need not wait that long, right? We can straight away start integrating some of the APIs, which we already doing at this stage.
Great. Yeah.
Now, similarly in your line of work, now all these APIs have been exposed in last 1 year or maybe and more are gonna come on the scene. Do you see any of the existing work, you're fast tracking any of the work that already been doing, or are you going to continue training or existing models? And then what happens some of the work you're already doing? Let's say the work you're already doing, maybe it was intended with a different result, different results in mind, but here you have something which might be giving a second result. So how are you going to balance that, and how are you going to see, fast tracking some of the existing processes?
Yeah, it's a good question. I mean, I think you're right. They're definitely going to be able to start using these models more efficiently. What ChatGPT does, and other these large foundational models will do, is they're leveraging a bit this idea of transfer learning to some extent. But for them, they didn't even have to transfer. It's kind of it's already sort of embedded in everything that they learn. But a method, right, a technique that others have been using is, you've built a large model and I want to apply it. This model has been trained for a specific task. I want to apply it to a new task. Well, instead of just training a model from scratch, from nowhere, you can actually use an existing model that has a certain set of parameters and essentially train it just on a little bit of data, but much less than what you would have to do if you started from scratch. And it would actually usually perform quite well. And that's what you call transfer learning, because you're transferring sort of the model to a new domain and training with new data. ChatGPT, in a way, is a little bit similar, because now you're using ChatGPT and you may be introducing it to the type of problem, maybe the workflow or the methodology. You may not have to send it much data at all because it has most of it, but maybe it just needs to know kind of the flow, right, of what you're trying to do so that it can make a recommendation or produce the output that you want. It's a little bit in that spirit. And I think in the space of research and health, it's going to happen too. It's a little bit, it's going to take a bit more time because these things, I think industry, especially in tech, things move really fast. And in research, it's not quite as fast, but I think more and more the new generation of researchers and folks who just come out from graduate studies or even postgraduate studies, they're really eager to leverage these new models, and I think we're going to see some really exciting things really soon. I work myself a lot on. I'm not using ChatGPT right now on any particular project, but I'm certainly excited by the types of models that you could work, especially on the natural language space. I'm not doing anything in natural language space right now. That's why. But for those who are,
Okay,
I think
makes
they should
sense.
definitely be exploring that.
Pretty cool.
Yeah, that's cool. Big questions.
Right. Okay, like considering where this whole AI space is headed, are you scared or are you excited?
I'm really excited.
Okay,
I think
great.
it's going to be great.
Sorry.
Awesome. Yeah. I think we're headed into a brave new world that's going to be a really positive one as long as we make good use of it. You know, with power, or with great knowledge comes and power with great knowledge comes both risks and benefits. But if we're careful and if we do things well, then it's going to be amazing. Yeah.
Cool. So any closing questions?
So I was curious, in the time that ChatGPT has come out, I've started noticing that the way that my brain works has changed to remembering information and digesting information, to connecting information and thinking of new ways to ask questions and explore the world. So I'm wondering, now that we're outsourcing so much of the, I wouldn't say simpler, but stuff that you can easily Google, since we're outsourcing so much of that information collection or generation to these models, how's it impacted the way you just your daily life, the way you think about things, your work, and how do you see the human brain evolving based on this?
Oh, that's a good question. Wow. We may need a whole other session on that one. In short, I think we are thinking more and more. I think it's a great point. We need to adapt to these models ourselves. And I think it's one of the great things about humans and biology in general is that we're able to adapt. And some will argue that's actually a really important trait of intelligence is adaptation. And maybe some of the AGI of the future will be able to really adapt. But what we're able to do is adapt, I think, to these new tools, and we need to learn how to adapt. And we will, because it's fundamental. These are huge tools. They're now part of our toolbox. And it will change the way that we think. I'm sure a lot of engineers now, especially like in the AI, they're not thinking so much about representing data structures in a traditional way. The way they think about data now is embedding. How do you embed data into this sort of manifold, these vector manifolds or tensor manifolds that are basically representations of the raw data that we see, the text that we read or the images that we see. And embed that in this sort of high dimensional space. You start to think almost that way because you are like working with this on a day-to-day basis. And I think that's actually a kind of a neat sort of a like after effect or side effect, I should say, of working with AI in that sense. But for those who actually interface with the AIs, like with the applications itself, they will adapt as well. They're going to have to learn, and it's going to impact us for sure. I'm not sure what to make of it yet. Like, I don't know. It's definitely gonna, like, just like the way we use our phones. Like we don't rely on our own memory as much as we used to because we're our phones. Yeah. And you could argue your phone is an extension of your body, right? It's becoming like we are becoming cyborgs, so to speak, right? We're becoming like these are extended memories of ourselves, and the AIs will be the same. But what that does is that gives us more cognitive reserve, right, to actually process and think about other things that we didn't have time to do because we have to focus so much on the more basic tasks of either memorizing or compiling things together, which the AIs will be able to do with us. So,
I still wonder how people before the smartphones, how would people drive on a highway? Because I just don't know how do you get from point A to point B without without a Google map showing. Yeah, right.
So I'm totally the same. I rely on it all the time.
Yeah, so now we kind of have an extended brain right now, so far this brain has been, at least the mobile, to think of it, might have been just a storage place, right? Additional, in the old school, I had additional storage disk or something. Now you have add additional processor, we're just gonna do more stuff. It's exciting times.
It's exciting.
Any closing thoughts, and also where could our audience find you? And is there anything that you would like to offer? Anything? If they need some help on some specific topics, where they could reach you?
Happy to reach out. Anybody can feel free to reach out. I'm on LinkedIn. Is probably the best way. It's a great network.
We'll put the link down in the description.
Sure. Yeah, definitely reach out. But last thoughts are, I think, thank you, Jeanson and Sunena, for inviting me, and I wish you a lot of luck in the next little bit. I think it's really great that you're thinking proactively about this, because that's really the way to go. Think proactively about how you're going to be working with AI and adopting AI for your projects and for your the types of solutions you want to bring to the universe, to your environment, to your niche.
Yeah.
So that you can really solve problems in ways that we just wouldn't be able to solve before. So
awesome. All right. Okay. Thank you. Yeah.
Thank you.
And then, thanks, Francis. Thank you, Sunana. This is a great conversation. I guess like a lot of interesting ideas.
Yeah.
This won't be the only conversation. Like, we like plan to keep this going. Like, maybe we'll have you like on this podcast some other time.
Happy to.
But thank you so much for it.
Amazing. Thank you.
Thanks, everyone.